Good morning, student. Today we will go for the discussion of mesh analysis, nodal analysis, and concept of dual and duality. So we are going for the mesh analysis. So you have to go for Kirchhoff's voltage law. So in the prerequisite, already you studied in basic electrical engineering. So the Kirchhoff's voltage law says that at any instant of time, the algebraic sum of the voltages in a closed path must be equal to 0. So in that, we are writing the rising voltages and drop in voltages. All these summation must be equal to 0. Then you conclude that the algebraic sum of the rising voltages must be equal to the algebraic sum of the drop in voltages. So in the same way, the equations here represented, those equations you can call it as equilibrium equations. Those are called equilibrium equations, are also called as instantaneous equations. So now I am taking the example of a 3-loop circuit. So 3-loop circuit, 3 loop currents I am taking. So I1, I2, I3, and I am assuming the 3 loop currents must be in clockwise direction. So the 3 loops must be in clockwise direction. So here I am going for the application of Kirchhoff's voltage law. So for this one, first loop, how we are writing the equation? So VA minus RA into I1 minus RB into I1 minus I2. So RB is a resistance. It carries two currents, I1 current and I2 current. But I2 current is opposite with respect to I1. So that's why you are writing the net current flowing in the RB is I1 minus I2. So the total summation of voltages is equal to 0. So finally, the value you are getting is RA plus RB into I1 minus RB into I2 is equal to VA. So this is your first equilibrium equation. Come to the second loop. So second loop, 3 resistors are there. So I am writing the first drop RB. So RB is combination of two currents, I2 current and I1 current. So the drop is minus RB into I2 minus I1. And the RC resistance, the current is I2. So the drop is minus RC into I2. And for RD resistance, the two currents are flowing, I2 current and I3 current. So I2 current is flowing from top to bottom. I3 current is moving from bottom to top, opposite direction. So the net current flowing in the RD is I2 minus I3. So algebraic sum of the voltages in a closed path must be equal to 0. So finally, after simplification, you are getting minus RB into I1 plus RB plus RC plus RD into I2 minus RD into I3 is equal to 0. So this is your second equilibrium equation. Coming to the third loop, so the drop across RD you are writing, so it is the combination of two currents. So with respect to I3, I2 is in opposite direction. So the net current flowing through RD is I3 minus I2. So now the drop is minus RD into I3 minus I2. Then RE, the current is I3, the drop is minus RE into I3, and the voltage source with respect to the current, the flowing is plus to minus. So that means it is in drop in direction. So that's why minus VB is equal to 0. So now after simplification, minus RD into I2 plus RD plus RE into I3 is equal to V minus VB. So this is your third equilibrium equation. So if you put the three equations in matrix form, so we can get RA plus RB minus RB 0 minus RB plus RC plus RD minus RD 0 minus RD plus RE, unknown currents I1, I2, I3, and right hand side VA 0 minus VB. So this is the equation you are getting. So once the calculation of delta. So what is your delta? Delta is RA plus RB minus RB 0 minus RB plus RC plus RD minus RD 0 minus RD plus RE. So this is your delta value. So the delta value determinant we have to calculate. Then for finding the values of I1, I2, I3, so replace the first column by RHS. So that is VA 0 minus VB. You can get the delta 1 value. Replace the second column by RHS. You can get the delta 2 value. Replace the third column by RHS. You can get the delta 3 value. So all determinants you have to calculate by using Cramer's rule. I1 is equal to delta 1 by delta, I2 is equal to delta 2 by delta, I3 is equal to delta 3 by delta. So like this you have to calculate the loop currents of a given electrical circuit using mesh analysis or loop analysis. So the same matrix equation you can get using Maxwell's. According to the scientist Maxwell's, so he says that so if n number of loops are there, you can get a n by n matrix. So in this example, 3 loops are there. The size of the matrix is 3 by 3. So 3 by 3 matrix means A11, A12, A13, A21, A22, A23, A31, A32, A33. So unknown currents are I1, I2, I3, and you can get a column matrix in the right hand side. So now what is A11? A11 means entire loop 1 connecting passive elements. So entire loop 1 connecting passive elements are RA and RB. So take the summation. So you can get RA plus RB. Then A12 or A21, loop 1 to loop 2 connecting element or loop 2 to loop 1 connecting element. So here it is RB. So we have to write A12 and A21 as RB, and half diagonal elements are always negative according to the direction of current. According to direction of current. Then A13 or A31. So A13 and A31 in this circuit you don't have any direct connection. Blindly put 0. Blindly put 0. Then coming to A22. So A22 is entire loop 2 connecting passive elements. So RB plus RC plus RD. So that is the value you are getting for A22. Then A23 or A32. So the connection between loop 2 and loop 3 or loop 3 and loop 2 is RD. So half diagonal elements always multiplied by minus sign. And the final value A33 is entire loop 3 connecting passive elements RD and RE. Take the summation. So this is your LHS part. While you are coming to the RHS, so the I1 current is flowing in the rising direction of voltage. On right hand side it must be positive. So the first loop we are having a voltage source, that is VA. So on right hand side it is a positive VA. So for coming to the second loop, you don't have any voltage source. Blindly put 0. Blindly put 0. Then coming to the third loop, so I3 current is moving from dropping direction of voltage, plus to minus dropping direction of voltage. So that's why you have to take a negative side. So while you are writing the equilibrium equations, putting in matrix form, so that is one method, or by seeing the circuit or by observing the circuit you can write the matrix is also another form. Okay. Now coming to the calculation, so once you calculated the delta, you have to go for the delta 1, delta 2, delta 3 by replacing RHS with respect to first column, second column and third column. Once you calculated the determinants of delta, delta 1, delta 2, delta 3, then you can go for the calculation of I1, I2, I3 as delta 1 by delta, delta 2 by delta, delta 3 by delta. So like that we have to calculate the loop currents. Next, coming to the example of mesh analysis. So here they are given the circuit. So for this circuit you have to go for the calculation of supplied power current. Supplied power current. So here 60 volts voltage source is connected. That current you have to calculate. They are given the nomenclature. I1 is the current you have to find. So 3 branches, 12 ohm branch, the current is I2. The current is I2. 6 ohm branch, the current is I3. Again one 12 ohm branch, the current is I4. So now the 3 branches are connected in parallel. The voltage must be same. Whatever the voltage drop across the 12 ohm must be same as voltage drop across 6 ohm, must be same as the voltage drop across another 12 ohm resistor. So now the 12 ohm current is I1, I2, the 6 ohm current is I3, the 12 ohm current is I4. So by observation you can write it as I2 into 12 must be equal to I3 into 6. At the same time I2 into 12 must be equal to I4 into 12, and also I3 into 6 must be same as I4 into 12. So these are the observations you are getting. So now apply the KVL in this loop. Now apply the KVL in this loop. So 60 volts is equal to 7 into I1 plus 12 into I2. So 60 volts is equal to 7 into I1 plus 12 into I2. So now by the application of Kirchhoff's current law, the total current I1 is divided into 3 currents: I2 current, I3 current, I4 current. So total current I1 is equal to I2 plus I3 plus I4, and substitute the I3 value in terms of I2 as 2 times of I2 and I4 value as I2, then I1 is equal to 4 times of I2. So now by substituting this in the equation, so you can get 60 plus 7I1 plus I2 is replacing as I1 by 4 into 12. So finally you can get 10 times of I1, then I1 is equal to 6 amperes. So like this you have to go for the Kirchhoff's voltage law or Kirchhoff's current law with the help of calculation of responses in particular branch. Next, example 2. So here they are given 3 loop circuit. So for this 3 loop circuit you have to go for the calculation of the current. So in this 3 loop currents I1, I2, I3 I have taken, which are in clockwise direction. So for this one I am writing the KVL. So the first equation is 60 is equal to 7 into I1 plus 12 into I1 minus I2. That is your first equilibrium equation for first loop. Coming to the second loop, no voltage source. So 0 is equal to 12 into I2 minus I1 plus 6 into I2 minus I3. So voltage drop across 12 ohms, voltage drop across 6 ohms. Next, coming to the third loop, so you don't have any voltage source. 0 is equal to 6 into I3 minus I2 plus 12 into I3. So if you simplify, you can get the first equation is 19 I1 minus 12 I2 is equal to 60. For the second loop, so minus 12 I1 plus 18 I2 minus 6 I3 is equal to 0. And the third loop, you can get minus 6 I2 plus 18 I3 is equal to 0. So if you put in the matrix form, you can get 19 minus 12, 0, minus 12, 18, minus 6, 0, minus 6, 18. The unknown currents are I1, I2, I3 and RHS is 60, 0, 0. Okay. So calculate the determinant of delta, calculate the determinant of delta 1, then I1 is equal to delta 1 by delta. So this determinant value after calculating you are getting 6 amperes only. So in previous example we are also getting the 6 amperes for the source current. So same example I have applied in the KVL using mesh analysis. Here also I am getting the 6 amperes. Okay, are you understand the difference? So coming to the next problem. So the problem they are given to go for the mesh currents. So here two voltage sources are there. So it is a 3-loop circuit. So for this 3-loop circuit, you are going for the calculation of I1, I2, I3. So let us assume the currents are flowing in the clockwise direction. So now I1 current based on first loop, I2 current is in second loop, I3 current is in third loop. So I am writing the mesh analysis. So n number of loops are there, n number of equations you can get, and the size of the matrix is n by n. So here 3 loops are there. The size of the matrix is 3 by 3 matrix. So first one is A11. A11 means entire passive elements. So loop 1 passive elements are 2 and 5. Take the summation, you can get 7. You can get 7. Then A12 and A21. Loop 1, loop 2, intermediate value is 5. So half diagonal elements are always represented with minus sign for clockwise direction. So you can get minus 5. A12 is same as A21. Then A13 and A31, you don't have direct connection. Blindly put 0. Blindly put 0. Then coming to A22, entire loop 2 connecting elements 5 ohms, 10 ohms and 4 ohms. So 5 plus 10 plus 4, you can get 19. You can get 19. Then A23 and A32. So it is the connection between loop 2 and loop 3. So what is that? 4 ohms. Half diagonal elements for the given direction of current it is negative. So minus 4 for A23, minus 4 for A32. Then coming to the A33. So A33 entire loop 3 passive element. So 4 ohms and 2 ohms. So 4 plus 2, 6 ohms. So then the unknown currents are I1, I2, I3. So while you are coming to the right hand side, so the first loop I1 current is flowing with respect to plus 2 minus direction. So plus 2 minus means it is a drop. You have to write with minus sign, minus 25. While you are coming to the second loop, the I2 current is flowing from minus to plus, rising voltage. So it is a positive voltage. So on right hand side, it is 25. So while you are going for the third loop, so the voltage source is moving from minus to plus direction of current. So rising direction, so it is positive. So once you go for the matrix, calculate the delta 1, calculate the delta 2, calculate the delta 3, then calculate those determinant values, then calculate I1, I2, I3 using Cramer's rule, delta 1 by delta, delta 2 by delta, delta 3 by delta. So from that you can get I1 value is minus 1.31 amperes, I2 value is 3.17 amperes, and I3 value is 10.45 amperes. So like this you have to go for the calculation using mesh analysis. Next example, so it is a 3-loop circuit. So for this 3-loop circuit, we have to go for the mesh currents I1, I2, I3. So this I1, I2, I3 are moving in clockwise direction. So 3 loops are there. You can get the 3 loop equations. So the first loop I am writing. So minus 7 plus 1 into I1 minus I2 plus 6 plus 2 into I1 minus I2. So this is your first loop. So the first loop having 2 voltage sources, 2 resistors. So minus 7 voltage drop across 1 ohm is I1 minus I2. 6 volts is a voltage source. 2 into I1 minus I3 is equal to 0. While you are coming to the second loop, only 3 resistors are there. So 1 ohm resistor, the voltage drop is I2 minus I1. 2 ohm resistor, the voltage drop is 2 times of I2. 3 ohm resistor, the voltage drop is 3 times of I2 minus I3. So all are voltage drops. Summation of voltage drops must be equal to 0. So that is your second equilibrium equation. So coming to the third loop, so third loop, 3 resistors are there, 1 voltage source is there. So 2 times of I3 minus I1 is the voltage drop across 2 ohm resistor. So minus 6 is the voltage source value. So 3 times of I3 minus I2 is the voltage drop across 3 ohm resistor, and 1 time of I3 is the voltage drop across 1 ohm resistor is equal to 0. So once you are represented these 3 equations, equilibrium equations, then you have to go for the simplification and you have to go for the Cramer's rule for calculation of delta, delta 1, delta 2, delta 3. Then I1 is equal to delta 1 by delta, you are getting 3 amperes. I2 is equal to delta 2 by delta, you are getting 2 amperes. And I3 is equal to delta 3 by delta, you are getting 3 amperes. So these are the loop currents you are getting after calculation. Next example. So now we are going for the current I1 in the circuit. So that is source current only. So this is the example of dependent sources. So there is a voltage source, so which is a voltage controlled voltage source. So which voltage? 4 ohm resistor voltage. So that is Vx. Voltage drop across the 4 ohm is Vx. So that voltage is controlled with respect to this voltage source. Okay. So now I am going for the loop currents. So I1 and I2, because 2 loops are there, I am taking clockwise direction. So with respect to source, the loop is I1 current. With respect to the left hand side, the loop current is I2. So now I am writing the KVL equations. So the first loop, so I am writing with respect to left hand side. So minus 5 minus 2 Vx plus 4 times of I1 minus I2 plus 4 times of I2 is equal to 0. So two sources are there, minus 5, minus 2 Vx. So 4 ohm resistor is combination of two currents. So that is 4 times of I2 minus I1 is same as Vx only, voltage drop across the resistor only. Then 4 ohm resistor, the drop is 4 times of I2. So this is the equation you are getting. So if you modify 4 times of I1 minus I2 plus 2 times of I1 plus 3 is equal to 0. And the second loop equation you are getting this. So in this 4 ohm resistor, the drop is I1 minus I2. 2 ohm resistor, the drop is 2 times of I1, and 3 ohms is plus 2 minus, we are taking the drops is equal to 0. Also Vx is voltage drop across the 4 ohm resistor. 4 ohm resistor current according to the direction of Vx plus 2 minus is I2 minus I1. So three equations are there. So three unknowns are there, Vx, V1, Vx, I1, I2. So calculate for I1 value. So if you calculate, finally you are getting as 4 I1 is equal to 5, or I1 is equal to 1.25 amperes. 1.25 amperes. Okay. Next problem. So another problem. So in this, one voltage source is there, one current source is there, one dependent voltage source is there. So we are going for the calculation of the current I in the dependent source branch. In the dependent source branch. Okay. So I am going for the clockwise direction of currents, small I1 and small I2, which are in clockwise direction. So I am writing the first equation. I am writing the first equation. So 2 minus 1 into I1 minus 2 into I1 minus 1 into I1 minus I2 minus 2 times of I1 is equal to 0. So this is your first equation. So if you simplify this, you can get minus 6 times of I1 plus I2 plus 2 is equal to 0. So now from the observation here, so I2 is opposite direction of current 2 amperes. So that means direction changes, sign will be changes, magnitude never changes. So I2 is equal to minus 2 times minus 2 amperes only, minus 2 amperes only. And while you are coming to the loop, the I1 current is 0. The I1 current is 0. So I1 minus I2 is a unconditional way. Unconditional way. So from that, 0 minus of minus 2 is equal to 2 amperes. 2 amperes. So that is the I value. So that is the I value. So here also we are getting the I value is same as 2 amperes only. 2 amperes only. So coming to the super mesh. So super mesh is one of the thing whenever there is a current source without any internal resistance connected in parallel, at that time you cannot write the voltage value of the current source. Voltage value of the current source. So at that time you have to go for the super mesh. So here this is the example, you have to go for the calculation of voltage drop across 4 ohm resistor. The value of voltage is Vx. The value of voltage is Vx. Okay. So I am taking the two loops, intermediate current value is a super mesh. So the I3 current is moving in the upward direction from bottom to top. So I2 is also in the same direction, but I1 is in the opposite direction. So you can write it as I2 minus I1 is equal to 3. So this is your super mesh equation. This is your super mesh equation. So then writing the overall loop by open circuiting the current source. So for first loop, 1 into I1 is the drop. So 1 ohm resistor drop, 2 ohm resistor drop is 2 times of I1. So finally you are writing as 1 plus 2 into I1. While coming to the right hand side, so 2 ohm resistor drop is 2 into I2, 4 ohm resistor drop is 4 into I2. So you can write 2 plus 4 times of I2 is equal to 0. So above equation, 3 times of I1 plus 6 times of I2 is equal to 0, and I1 minus I2 is equal to 3. So solving the two equations, you can get I1 is equal to minus 2 amperes, I2 is equal to 1 ampere. Then what is Vx? Vx is voltage drop across 4 ohm resistor. What is your 4 ohm resistor current? I2. So Vx is equal to 4 I2. So that is equal to 4 volts. So like this, you have to go for the calculation of mesh analysis problems. Are you understanding all of these, students? So try to solve some more problems for practicing with respect to different skills developed in the subject. So next, coming to the nodal analysis. So in this nodal analysis, the main thing I am taking the consideration as, while writing the nodal equations, all currents are away from the node. All currents are away from the node. So if you are writing the first node, so here I have represented the 3 currents at the node. So they are away from the node only. So while I am writing the second node, so here also all currents are away from the node only. So like that, I have to taken the assumption all currents are away from the node, so that algebraic sum of the currents must be equal to 0. So nodal analysis is the Kirchhoff law only. So what is the statement of Kirchhoff law? At any instant of time, the algebraic sum of the currents must be equal to 0. Must be equal to 0. Okay. So to go for the nodal analysis, so you have to go for principal nodes only. So if you see in the representation, node 1, node 2, node 3 are principal nodes. So these principal nodes are 2 or more branches are meeting at a point, then you can call it as a principal nodes. While we are coming to the node 4 and node 5, they are simple nodes. Only 2 terminals are connecting at a point. So you have to consider only principal nodes. Then one of the principal node must be considered as a reference node. So here the node 3 at the bottom side I am connecting as a reference node. So this reference node, the voltage must be always 0 because it is grounded. So now I am writing the first node equation. So node voltage V1. So for this V1, I am writing the expression for Kirchhoff's current law. So V1 minus VA divided by RA, that is first current. So second current, V1 minus V reference by RB. Anyway, V reference is 0. V1 by RB. Third current, V1 minus V2 by RC is equal to 0. So if you put in matrix form, so you can get V1 into 1 by RA plus 1 by RB plus 1 by RC minus V2 into 1 by RC is equal to VA by RA. So this is your first equilibrium equation. So while you are coming into the second node, so at second node, so I am taking V2 is the node voltage. So here also 3 branches are meeting at a point. So you can get 3 currents. So the first current is V2 minus V1 by RC. Second current is V2 minus V reference by RD. So anyway, V reference is 0. So V2 by RD. And the third current is V2 minus VB by RE. So 3 current summation must be equal to 0. So after simplification, minus V1 1 by RC plus V2 into 1 by RC plus 1 by RD plus 1 by RE is equal to VB by RE. So this is your second equilibrium equation. So if you put in a matrix form, so if you put in a matrix form, you can get a 2 by 2 matrix. So A11 is 1 by RA plus 1 by RB plus 1 by RC. So A12 and A21 is minus 1 by RC, and A22 is 1 by RC plus 1 by RD plus 1 by RE, and the unknown node voltages are V1 and V2, and the right hand side equation is VA by RA and VB by RE. So once you calculate putting in the matrix form, so you can calculate the delta. So delta is 1 by RA plus 1 by RB plus 1 by RC minus 1 by RC minus 1 by RC, 1 by RC plus 1 by RD plus 1 by RE. So then calculate delta 1, replace the first column by RHS, calculate delta 2, replace the second column by RHS. Once you calculated delta 1, delta 2 determinants, then you can calculate the node voltages V1 and V2, instantaneous node voltages V1 and V2. So in this observation, if n number of principal nodes are there, n number of principal nodes are there, the order of the matrix is n minus 1. The order of the matrix is n minus 1. Okay, so that's why 3 principal nodes are there. So you are getting a 2 by 2 matrix. So because whatever the third principal node you are taken as a reference, so reference is a fictitious node. It never appears at the output side. It never appears at the output side. Are you understanding? So similarly, you can go for the nodal analysis using Maxwell's. Okay, by seeing the circuit, you can write the matrix equation. So here n number of principal nodes are there. The order of the matrix is n by n matrix. So you can get 3 minus 1, 2 by 2 matrix you can get. So 2 by 2 matrix means A11, A12, A21, A22. So what is A11? A11 means entire node 1 connecting passive elements. Entire node 1 connecting passive elements. So RA, RB, RC. Take the reciprocal and sum. So 1 by RA plus 1 by RC plus 1 by RC. So you are getting the same value as A11. Then coming to the A12 or A21. So node 1 to node 2 connecting element or node 2 to node 1 connecting element. So what is that? RC. So take the reciprocal, since half diagonal elements must be negative. So minus 1 by RC minus 1 by RC. Next, coming to the A22. So A22 means entire node 2 connecting elements. So entire node 2 connecting elements are RC, RD, RE. Take the reciprocal and sum. 1 by RC plus 1 by RD plus 1 by RE. So finally you can get the A22 value. So which is same, and the node voltages are unknown node voltages. So V1, V2. Then coming to the RHS. So with respect to VA and VB, both are in rising direction. Both are in rising direction. So voltage divided by that internal resistance value. Voltage divided by that internal resistance value. So you can get VA by RA, VB by RE. So like this also you can write the matrix by direct observation using Maxwell's. Okay. So now we are going for the simple examples of the nodal analysis. So for the given circuit, you have to go for the calculation of node voltages V1, V2, V3. V1, V2, V3. Okay. So identify the principal nodes. So in the problem itself they are given. So V1, V2, V3 are the principal nodes, and one is a reference node here. So this reference voltage must be 0. This reference voltage must be 0. So now this node voltage V1 is 12 volts only. So V1 is directly 12 volts. So V3 is also directly 6 volts. So only you have to go for node 2 equation. You have to go for node 2 equation. So how we are writing the node 2 equation? Three currents are there. So V2 minus V1 by 12K, one current. So V2 minus V reference by 6K, another current. V2 minus V3 by 12K is equal to 0. Is equal to 0. So here already V1 value is 12 volts, V3 value is minus 6 volts. So you can calculate the value of V2. So finally you can get 1.5 volts. 1.5 volts. So a very simple problem. Okay. Next problem. So here you have to go for the node voltages VA, VB for the given circuit. So three principal nodes are there. So this is one principal node voltage is VA. This is one principal node voltage is VB, and this is your reference node. This reference node voltage must be always 0. So while you are going for writing of the Kirchhoff's current law with respect to nodal equations. So here we are going for calculation as three currents with respect to node 1 and also with respect to node 2. Three currents are there. So the first node, so VA by 4 plus 3 plus VA minus VB by 2. So after simplifying, so you are getting 1 by 2 plus 1 by 4 into VA minus 1 by 2 into VB is equal to minus 3. While you are coming to the second node B, so VB minus VA by 2, VB minus V reference by 3 minus 4 is equal to 0. So after simplification, so you are getting 1 by 2 plus 1 by 3 into VB minus 1 by 2 into VA is equal to 4. So once you represented in the matrix form, then you have to go for the delta. Then you have to go for delta 1, replace the first column by RHS. Then you have to go for the delta 2, replace the second column by RHS. So delta, delta 1, delta 2 determinants you have to calculate. Then you have to go for the calculation of VA, VB. So what is VA? Delta 1 by delta. What is VB? Delta 2 by delta. So finally you are getting minus 4 by 3 is the VA value and 4 is the VB values. So once you are calculated, so they are asked to find the current flowing through 2 ohm resistor. So 2 ohm resistor positive value you have to get, means you have to take VB minus VA by 2, because VB is a highest value as compared with VA, so that's why VB minus VA voltage divided by resistance 2 ohms. So finally you can get 8 by 3 amperes. So if you go for the direction of current in opposite also, you can get the same magnitude, but only sign changes. So that is I2 is equal to VA minus VB by 2. VA minus VB by 2. So you can get minus 8 by 3. So like this also you can get. So remember all the students, direction changes, sign will be changes, magnitude never changes. Okay. So next, coming to the another example. So a current source is there, a dependent voltage controlled current source is there. So now we are going for the calculation of Is. So that is unknown value. So for this unknown value, you have to calculate and assume that they are given the V naught value is 60. So what is your V naught? V naught is the voltage drop across 8 ohm resistor. V naught is the voltage drop across 8 ohm resistor. Okay. So now I am going for the nodal analysis. So KCL I am applying at node B. At node B. So here, so 1/4 times of V1, it is a current source. So this current source is equal to 2 amperes they are given plus IA plus IA. So I am going for the nodal analysis at node A. So here Is is entering, Ia is entering. So Is plus Ia is equal to Is plus Ia is equal to what is this node voltage current at this node? V1 by 6. V1 by 6. So now VA is V1. VA is V1 because this node voltage is V1. This node voltage is V1 is same as VA only, and VB. So VB, this node voltage is V0 only. So what is that V0 value? 60. So now VB minus V1. VB minus V1 is from this above two expressions you are getting as 4IA. 4IA. So V1 minus VA is equal to 12 volts when IA is equal to 1 ampere after getting the solution. So therefore Is is equal to 1 ampere. Therefore Is is equal to 1 ampere. So the magnitude of the dependent current is how much? 3 amperes. So this current is how much? 3 amperes. So V1 is substituted with respect to the value, then you are calculating the current. So finally you are getting that value is 3 amperes. So once you are calculated with respect to this, you can go for the calculation of powers also. So source power, dependent source power is 48 watts. So source power of Is you can get 60 watts. So the resistor consumed by the total network is also 60 watts. So this is law of conservation of power. This is law of conservation of power. Okay. So next, coming to the another example. So you have to go for the determination of dependent source power supply. That value you have to calculate. So here I am going for the nodal analysis. So I am taking the node voltages as V1, V2 and V reference. So here I have represented. So with respect to that I am writing the expressions. So here for the node 1, the node voltage is V1. So I am writing the nodal equation. 15 amperes is entering. V1 minus V2 by 1 is the current flowing through 1 ohm resistor, and V1 by 2 is the current flowing through 2 ohm resistor. So that is your first equilibrium equation. Then while coming to the second node, so here 3 currents are there. So one is 1 ohm resistor current, another one is 3 ohm resistor current, and another one is dependent current source. So 3 times of I1 is equal to V2 minus V1 by 1 plus V2 by 3. V2 by 3 because all this part is connected to reference. So this reference voltage must be equal to 0. So once you are writing the nodal equations, so by using the application of Kirchhoff's current law, so now what is the I1 value? So I1 is V1 by 2. So I1 is V1 by 2. So in this expression, so I1 is the current flowing through 2 ohm resistor, and voltage drop across 2 ohm resistor is V1. So I1 is equal to V1 by 2. So substitute in the above equations. So three equations are there: I1, V1, V2. So finally we are getting, after modification, as 3V1 minus 2V2 is equal to 30, and minus 15V1 plus 8V2 is equal to 0. So by calculating Cramer's rule, or you can go for the general mathematical solutions. So you can get V1 is equal to minus 40 and V2 is equal to minus 75 volts. So now what is I1? I1 is equal to V1 by 2. So I1 is equal to V1 by 2. So that is, if you substitute V1 value minus 40 divided by 2, you can get minus 2 amperes. Minus 2 amperes. And they are asked the power supplied by the dependent source. So power is equal to voltage into current. So minus 60 into minus 75, you can get 4.5 kilowatts. Next example. So another example, you are going for the current flowing through 15 ohm resistor. So 15 ohm resistor is connected between the nodes, so V1 and V2. So we are going for the Kirchhoff's current law. So the first node is 2 amperes is entering. So here three currents are there. So first current is 2 amperes is equal to V1 divided by 7 plus 3. So 7 plus 3 means 10. So V1 by 10 plus V1 minus V2 by 50. So this is your first equilibrium equation. Going for the second node. So here also you are having three currents. So V2 minus V1 by 15 plus V2 by 5 is equal to 4. Or 4 is equal to V2 by 5 plus V2 minus V1 by 15. So two equations, two unknowns. So if you go for the Cramer's rule, so you can get V1 is equal to 20 volts, V2 is equal to 20 volts. So now the two voltages are same values. So what is the current flowing through 15 ohms? So minimum knowledge, you can say that the difference between the potential for a 15 ohms is either V1 minus V2 or V2 minus V1. So 20 minus 20, you can get 0. So the net current flowing in 15 ohm resistor is 0 only. Now coming to the another example. So here we are going for the calculation of Kirchhoff's current law. So the entire circuit is represented. So we have to go for the node voltages. So node voltages, we are assumed V1, V2, V3 and reference node. So now one by one node, we are writing the expressions. So for first node, so how many branches are connected? 1, 2, 3, 4 branches are the connected. So 2 are the current sources, 2 are the resistors. So minus 8 minus 3 is equal to V1 minus V2 by 3, V1 minus V3 by 4. This is your first nodal equation. Next, coming to the node 2. So node 2, how many branches are there? 4 branches are there. 1 current source, 3 resistors are there. So minus of minus, actually 3. So 3 is equal to V2 minus V1 by 3, V2 minus V3 by 7, V2 minus V reference by 1. So V2 minus V1 by 3, V2 minus V3 by 7, V2 by 1 is the total nodal equation. And the third node, so third node, how many are connected? So 4 branches are there, 3 are resistor, 1 is a current source. So here also the current is leaving, so positive current only, minus of minus 2.5. So now V3 by 5 or V3 minus V reference by 5, this is one current. So V3 minus V2 by 7, this is one current. V3 minus V1 by 4, it is another current. So three equations, three unknowns. So go for the Cramer's rule, delta, delta 1, delta 2, delta 3. So you can get the determinants with respect to delta 1 by delta is V1. So that is 5.412 volts. For V2, delta 2 by delta, so that is 7.736 volts. And for V3, delta 3 by delta, you can get 46.32 volts. So like that, you have to go for the nodal analysis problems. So now we are going for the special case as a super node. So in the figure, we have to go for the calculation of node voltages VA and VB. So this is your VA value. So this is your VB value. So between node A and node B, there is purely a voltage source. They are not represented the series resistance. So that's why you cannot write the current value. You cannot write the current value. So at that time, you have to go for by short circuiting the terminals A and B and making that node as a super node. That node as a super node. Okay. At the same time, with respect to the potentials, at node A side is minus, node B side is plus for 12 volts. So that means VB minus VA is equal to 12. So lower potential to higher potential. Node A is a lower potential, node B is a higher potential. So node B minus node A is equal to 12 volts. So coming to the super mesh equation for first node, so it is minus 1.5 amperes plus VA by 6. VA by 6. So these two currents are completed. These two currents are completed. Now coming to this side, so plus 3.5 amperes, then VB by 3. So VB by 3. So finally you are getting VA plus 2VB is equal to minus 12. So equation 1, equation 2. So if you solve, you can get VB is equal to 0 and VA is equal to minus 12 volts. So like this, you have to go for the super nodal analysis or nodal analysis for any electrical circuits. So remember, students, any electrical circuit can be calculated using Kirchhoff's current law, that is nodal analysis, Kirchhoff's voltage law, that is mesh analysis, any network theorems, network reduction techniques, network topologies. Finally, you have to get the unique value only. You have to get the unique value only. And there is a lot of applications in the KVL and KCL. So for all electrical students should learn this KVL and KCL particularly, because for a lifelong learning you have to go for these two methods. Either in the third year level, final year level, or if you go for any advanced studies also, these two are the basic principles, and also Ohm's law. Okay. At the same time, the main disadvantage of mesh analysis or nodal analysis is the complexity of the network is increases. So it is very difficult to go for the calculation. So in the sense, the time will be very more. For calculation part, time will be very more. So at that time, you have to go for network topology, or you can go for reduction of the network techniques, either star to delta transformation, source transformation, or series parallel combination connections, or you can go for the equivalent circuits such as Thevenin's, Norton's. So like that, so many sources are there. You can go for the superposition theorem also. You can go for the superposition theorem also. So all these are the overview of the topics, and the last topic is duality for dual circuits or dual networks. Okay, so what is duality? Duality means it is the circuits which has same equations, but there is a change in the notations. But there is a change in the notations. Those things or those networks, you can call it as a duality networks with respect to behavior of dual, with respect to behavior of dual. So the same equivalent circuit must be represented in another way. The equations you are getting the same, the mathematical equations of first circuit and second circuit are almost similar, then you can say that the two networks or two circuits are under duality, under duality. So in this case, for electrical uh, components, so there is a duality between series connection and parallel connection. There is a duality between integral differential equations of loop and integral differential equations of parallel. So that means voltage source can be replaced by a current source. Then automatically the equations will be almost similar, almost similar. Okay, so whenever the two equations are almost identical, then you can say that they are the property of duality, they are the property of duality. So now coming to the dual networks. So what are the pairs you are having dual in case of electrical elements? So voltage source dual with the current. Current is also dual with the voltage. So voltage by Ohm's law V is equal to IR. Current by Ohm's law I is equal to V into G. Okay. So short circuit is dual with open circuit. So series connection is dual with parallel connection. Norton's theorem is dual with Thevenin's theorem because it is source transformation only. So resistor is dual with conductance. Capacitance is dual with inductance. Inductance is dual with capacitance. Kirchhoff's voltage law equations are dual with the Kirchhoff's current law equations. So open switch is dual with the closed switch. Mesh equations are same as nodal equations, duality in the sense of duality. So voltage source can be replaced by a current source. T networks is dual with the pi networks. So like this, all these are the duality between the series combinations with respect to parallel combinations. So how we are formulating the dual network? So there are some test steps are there. So with respect to those steps, you have to go for the formulation of dual network from one circuit to another circuit. Okay. So for formulation, so the first step is, if the circuit they are given with n loops, we have to take n plus 1 nodes. So that means n loops are there, we have to go for n plus 1 nodes. So each node must be represented at the center point of the loop, at the center point of the loop, and take one notation. So for example, n loops are there. So 1, 2, 3 and so on, n plus 1 nodes we have to represent, and the last node must be represented outside the entire network, outside the entire network. So and that node is a fictitious node and which is connected to the grounded or reference, to the connected to the grounded or reference. Okay, so then you have to draw a dotted line replacing by each element connected between inside the loop node to the reference node, inside the loop node to the reference node. So like that, if resistor is there, replace with a conductor. If inductor is there, replace with a capacitor. If capacitor is there, replace with a inductor. If open switch is there, replace with a closed switch. If voltage source is there, replace with a current source. Like that, you have to draw the individual values with respect to dotted and replacement of the element with dual elements. So similarly, when there is a connection between loop to loop, so that also you have to take individually. From loop 1 to loop 2, two dots here represented, and each element must be taken individually. At the same time, the current sources or voltage sources must be taken individually. So like that, you have to go for the formulation of dual networks. Formulation of dual networks. So to understand this, I am going for the simple examples. So let us take the original network. This is a original network. So voltage source, two resistors are there, two capacitors are there, one inductor is there. So I am formulating the duality and I am writing the, or I am drawing the dual network. Okay. So here, so first you have to go for the individual loops with nodes and outside node, and outside node must be a reference node, so represented here. So each element must be connected to loop to reference, are you understanding? So each element here connecting with loop to reference and replace with the dual elements, and intermediate between the elements also you have to consider. Intermediate between the elements is also considered. So here voltage source is replaced by current source. So capacitor is replaced by inductor. Resistor is replaced by conductor. So inductor is replaced by capacitor. Capacitor is replaced by inductor. So this resistor is replaced by conductance. So finally you can get the dual network like this. So similarly, one more example. So here, two capacitors are there, one voltage source is there, one current source is there, two inductors are there, and one resistor is there. So two loops are there. So we have to go for 2 plus 1. So and the outer node must be taken as a reference. So the voltage source I have to connect like this. The current source between the node loops you have to connect like this. So the capacitor I have to take like this. So the resistor I have to take like this. The inductor I have to take like this. The capacitor I have to take like this. The inductor I have to take like this. So the series elements are formed as a parallel. So inductor is replaced by capacitor, capacitor is replaced by inductor, resistor is replaced by conductor, current source is replaced by voltage source is replaced by current source. So here only two nodes are there. So only two nodes is there. So there is a voltage source replacement of current, and remaining these are three branches. We are represented like this. So as shown in the dual elements. So this is the concept of duality and dual networks. So please go through the numerical problems to get the skills in the subject. Thank you one and all.